Before starting, I would like to thank the Linux user group of Mauritius for organizing this conference while I'm in vacation. And I'd like to also give a special thank to Jochen, so Dankeschön, for sponsoring the event. And yes, so I think we can start. So I have made a little agenda for tonight. There is a lot of slides, so I will try to go as fast as possible to cover them in the next 1 hour, 1 hour and a half. If I go too slow or too fast, please tell me. And if you have any question during the conference, please, you are welcome to stop me and to ask a question. I love questions. So we're going to talk about SkySQL. So SkySQL is the company I work for. Then we will present what are the high availability solutions available for MySQL and MariaDB. We will go over the history of MariaDB and show the features, the difference between MariaDB and MySQL. And we will also give some highlights on the new version of MariaDB, which is MariaDB version 10, on the features. Okay, so this will not be not so long. So I will give a short presentation of myself. So my name is Joffrey Michaie. I am French, based in Spain. I used to be a system administrator from 2002 to 2009 in various companies. One of them was Link-by-Net, so I know some of the local people are still or have been working at Link-by-Net. Then I joined MySQL, which was already Sun Microsystems in 2009 as a consultant. And in 2010, Oracle bought Sun Microsystems, for those who don't know. And I joined SkySQL 2010, and since then I am working as a consultant there. So what is it to work as a consultant for MariaDB or SkySQL? It's on-site and remote consulting. The main duties are performance and tuning. So your database is slow, it's too big. You need help to tune it without adding more hardware. So this is where we come in. You have a new application you are designing and you want to have the best schema for scalability and high availability. We do migration. So we migrate Microsoft, MySQL, Oracle, Postgres, SQLite to MySQL and MariaDB. High availability, a lot of people start with one single server for the database, and then the database becomes the heart of the system, so you need to make it highly available. And also, my main specialty is MySQL cluster, so it's another technology based on MySQL.
You mean with about clustering and cloud computing style, or?
So MySQL cluster is a technology based on MySQL, and it's for cloud or in-house system. So it's a storage engine that is mainly intended for telecoms, which was invented by Ericsson and bought by MySQL a few years ago. We want to see what the life of a consultant looks like. So this is almost 600 flights in 5 years. So we have customers all around the world, mainly in Europe and North America. Hopefully soon some in Mauritius. 2003, more than 30 million, and the number is growing, active installations. And MySQL was founded by a Finnish and the Swedish guys, so Monty Widenius and David Hartman. And the name MySQL is based on the name of the daughter of Monty Widenius, which is Moo, and that you write M-Y. That's for the story. Some examples of customers, some customers from SkySQL are the Telecom, Craigslist, Booking.com, well-known on trading screen. We have today more than 400 customers in 30 countries, so you may recognize some names. And it's growing. About the management, so the CEO is Patrick Steiner. He used to be a high executive at F-Secure. CTO is Ivan Zorati, which was field services director at MySQL. We have other quite famous names in the MySQL world that are working for the company. And we are backed up by an engineering team, which was called Monty Program. What is the engineering team? It is 20 original developers from MySQL. So the people that develop the query cache, the optimizer, some storage engines, they are working today at Monty Program, and they are developing something called MariaDB. You can choose, we advertise ourselves as the alternative to Oracle. So this is the Oracle CEO's yacht on the background, and this is one of our founders, David Armstrong. What does SkySQL do? We are a central point for your database. We do services, so our main service activity is support. So you have 24/7 support for your database installation. It can be MySQL, it can be MariaDB, and can be any of the third-party components that are pluggable in MySQL or MariaDB. We do create patches for MySQL and MariaDB. So if you find a bug in the software, we can provide you a patch version that fixes the bug, and in the meantime, we will give you a workaround during the development. Switch to the high availability presentation. So what solutions do you use for making MySQL or MariaDB highly available? Or do you have it in a highly available infrastructure? Okay, so praying is good. MySQL is very stable, and the hardware is more and more stable. But when you have a critical business running on MySQL, and you're generating hundreds or thousands of euros per minute, just a simple server reboot can cost you a lot of money. So you need, the more your business grows or the more critical it is, to make MySQL highly available. On this presentation, we show you what are the high availability solutions that you can deploy for MySQL and MariaDB. So availability is counted in nines, and each 9 is after the comma for the 99% availability. If you can afford to have your server down 36 days per year, some people do, that is 1/9, that is 90% of availability. If your system is more critical, you will want to grow how many nines you put in the formula. And 5 nines is actually the highest level of high availability you can achieve with MySQL. That means 5 minutes of non-planned downtime per year. We are going to use some terminologies. So we talk about synchronous versus asynchronous, shared disk versus shared nothing versus shared memory, single point of failure, failover, switchover, split brain, and node fencing and Cora. So first, before thinking about high availability, you need to plan what is the level of high availability you need. Because if you put 2 big solutions for a low critical platform, it may cost you much more, and the reverse is also valid. Do you require no loss of data? Can you accept to lose data? Will your users notice if you lose data? One example is when you do ad serving, so you serve millions of ads per minute. Losing 10 seconds of data may not be so important, because with the whole day data, you can almost recreate the data that you have lost. If you are doing financial transactions, so payments, what happens if a customer is billed on his credit card, but you don't have any trace of the order? That is more problematic. Do you need automatic failover, or can you do only manual switchover? Can you provide a reasonable service recovery when a node is down? The first solution for making MySQL available is called replication. This is a historical built-in feature of MySQL. It is available for more than 15 years now, so it has been tested and proved. It works in an asynchronous way, in a three phase. So you have one server that is the master, on which you do read and write operations, and you have one or n servers that are slaves. Your application does transactions or writes to the master server, and this master server, when it is replication aware, will write the list of changes you do to the database to a file called a binary log. So this is a file containing what are the changes that have been done in your database. This file is then sent over the network to replicate its slaves. The slaves receive the events, and the last step, step number 3, the slave will read the binary log file and will execute the event. So this is asynchronous. That means that when the write is finished on the master, we don't wait for the slave to receive the data or to acknowledge it or to apply it. We just say to the application, your transaction is completed. In later, which can be a few milliseconds or can be many seconds or minutes, the slave will receive the transaction workflow and will apply it and make it available on their own code. It is a master-slave relationship. There are some more complex topologies where you can do master-master, but it has quite some risks, so you have to be careful in the topology you deploy.
What is the time frame about, let's say, to replicate about 80 servers from one master ongoing?
There is no particular time frame. It is in milliseconds. It is depending on what transactions you are doing, what is the size of the data, what is the hardware, if you put the same hardware or not hardware.
And how detailed can you do the transactions? I mean, is it per database, is it per table?
So by default, it is everything. So we are replicating everything. Every single transaction you do on the master.
Per server, it's not.
It's by server. It's by MySQL instance.
By instance?
Yes.
So, okay, for instance, compared to SQL Server, it's a situation that you can really say per table that you can replicate. So you're not that far down yet.
We do, yes. So by default, it is one instance that you replicate entirely to one other. Yeah. And you can go to the table level.
Okay.
You can put a list of schemas on a list of schemas on the list of tables that you do replicate.
No, I mean, it's also a question about, let's say, partitioning data, where you say, okay, I have in my scheme or multiple schemes, I have certain information that is, let's say, branch related, and it's not about to replicate it, whereas on the other side, I have information in the same database that is general availability over all branches. So actually, I need to have the possibility to split, to say, okay, that data is not replicated, that data is replicated, and from. So this is also possible.
This is possible. So you can filter on the master side, where you say, I do write in the binary log transaction from this table, this table, this table, or this database, this database, this database. Or you can not filter on the master, but do specialized slaves, which are replicating only some particular schemas or some particular tables. Advanced slave. Promote the slave to master, and it can also shut down the original master, because you may not want him to come back after a few hours and be part of the replication. And this is all fully automated. This is open source. And yeah, a great addition to your replication. And last high availability solution possible with MySQL is called MySQL cluster. So have you heard about MySQL cluster? Is someone using MySQL cluster?
I worked on one, but I didn't install it. It was already there. Okay.
MySQL is and has been open source, so everybody is allowed to download it, enhance it, and distribute it as open source, and maybe as another name. So it is backward compatible drop-in replacement for the MySQL database server. It is fully open source, so all the source code is publicly available. 100% of the code is open source, so I don't know if you are using MySQL 5.5 or 5.6. They have added enterprise level features that are available only for enterprise subscriptions. So this is closed source code that you can add to MySQL. The database, the bug database is also fully open, and even the way the company works, except the salary, is fully open. So you can go to the website and find what are the company policies, the employee benefits, etc. So this is really open source philosophy.
What are the reasons that you forked off MySQL?
So we were all working at MySQL on that Sun, and then Oracle acquired Sun, and they changed completely the way to do the business.
So it was just working environment?
Yes. It's, when it was Sun, MySQL was still a small village within the big Sun ecosystem, and we were allowed to advertise open source and to do a lot of things. When Oracle came in, they changed everything. Community oriented. So we asked the community what are the features they would like to be in the next release. We asked the customers what are the features. We accept community contributions. So if you have created a feature in MySQL or MariaDB, we accept it and we include it potentially in the mainstream MariaDB. The goal of this software is to provide community-developed, stable, and free database. We have what we call MariaDB captains. So DBA, main DBA at Twitter, main DBA at Google, main DBA at Facebook. They are MariaDB captains, and they have high power on voting on what will be included in the next release. And it is an open development model, as I said. So, what is MariaDB 5.1? It is MySQL 5.1. So we took a complete copy of MySQL 5.1. And then we added storage engines, so more features out of the box. We fixed these bugs, thanks for the comment. So we fixed bugs that were not fixed in the mainstream MySQL. And we also removed what is called a mutex. So it is when you have high traffic platforms, you have sometimes too much logging inside the database. So we have removed this to accept more transactions per second on the same hardware. We added microsecond support in columns and in functions. We also have in the process list. We added something called a thread pool. So when you have 10,000 people connecting to MySQL and they try to run a query, that is not possible because the server will just go down. So a thread pool is a separate list of threads that are scheduling internally inside MariaDB how the query are executed. Otherwise, we would rely on operating system, but operating system is not MySQL aware. This is inside the MariaDB server. We added something called table elimination. So I don't know if you use views in your application. When you use a view in MySQL, the view is so from the actor name, birth date, and rating table. And if you query the view, but you don't want the birth date, MySQL will still query the birth date table and will scan it with the left join, and that can take quite a long time. MariaDB detects it and removes the table while it is executing the view. So you have faster views out of the box.
How does this happen based on your...
So based on the query. So here I'm not asking for the birth date on any columns from the birth date.
So actually while compiling the query, it does the elimination.
The query is compiled at each query.
Yeah.
So it is on the fly table elimination. In November 2010, we released MariaDB 5.2. And what is MariaDB 5.2? It is MariaDB 5.1, which is MySQL 5.1, plus all the features of MariaDB 5.1, plus pluggable authentication. So you can now connect with the LDAP to MySQL. That is a closed source feature from MySQL, not Oracle. We added some detailed statistics about how many times a remote host has read rows, used CPUs, etc. How many times an index was used, how many times records were retrieved from a table. This is 0.1 performance penalty when you enable it, and that gives quite some valuable information. We added something called virtual columns. So this is computed columns on your tables. We added the Sphinx storage engine. So I don't know if you know Sphinx. It's a full text search open source software. And now you can create Sphinx tables inside MariaDB, and you can query in the same query your data on the fast full text search software. And some optimizations in the MyXam storage engine. And here we can see, so this is the query per second with the MyXam cache optimization disabled and with the MyXam cache optimization enabled. So from about 5,000 to 6,000 to 20,000 if you have 64 and 128. January 2012 came MariaDB 5.3. So it is MariaDB 5.2 plus handler socket. So it is a low-level access mechanism for your InnoDB tables. With this handler socket, you can do 400,000 queries per second on a single server on InnoDB tables. We added dynamic columns, which is for data warehouse mainly. So you don't need to create hundreds of columns to store your data. You have only one column, and you have functions to access the data in your web. So I don't know if you can see well, but we have here a web shop, and in our items we have a t-shirt, we have a phone, another phone, and a ThinkPad. And the ThinkPad has an operating system, but the t-shirt doesn't have operating system. So to store all this information in a web shop, you will need to have a lot of columns, one for the operating system, one for the color, one for the model. While here, we have only one column that is called dynamic string. And this is storing all the information from different types of articles in the same column. And then you have functions to retrieve the information, to compute the information, and you can also index dynamic columns. We have optimized replication, so a lot of optimizations. We have added what is called a user feedback plugin, so your database can send anonymous information to the MariaDB developers so that they know what features are more used and they will concentrate on this one. And some GIS functionalities that have been included and that are being improved. There is progress reports when you do a alter table operation on a 500 gig table. Before, you didn't know when it was going to complete. So your manager comes until when the database is done. DBA says, I don't know. Now, you have a percentage within the command line or within the process list that tells you at what step you are on the table operation. So you can say it is 20%, it was running for 20 seconds, so expect 4 times 20 seconds before it completes. A lot of optimizations, but I would say the main optimizations that have been done in MariaDB are related to the optimizer. So the optimizer is what transforms your query into something, into some MySQL language, and it says in which order you read the tables, what index you use, etc. And a lot of work has been done on the optimizer. And before, when your application was slow, we came to your place and we were saying to the developer, you need to change this query, or this query, because it is not optimized. MariaDB detects less optimized query and will rewrite them on the fly for you. So we have seen queries taking 10 minutes on a standard MySQL. We just switched to binaries to MariaDB, and the 10-minute query was down to 1 second. It was using Hibernate on Python.
What's the situation about, do you have also then the possibility to, let's say, analyze your queries and do manual modifications, like comparable, like you have the, what is it?
Procedure analyze?
Yes.
Okay, so this is a built-in feature that tells you what is the best storage type for your columns based on your data. But no additions on this feature. optimizer control is what you can enable, which feature of the optimizer you can enable within MariaDB. And it has more than 40 different switches, while on MySQL you have 3 or 5 in MySQL 5.5, and maybe 10 in MySQL 5.6. So this is to show how deep you can control the efficiency of your queries. You can use subqueries now, thanks to the optimizer team. And you don't need to rewrite them into joins or into separate queries, because MariaDB does it out of the box. So if you have a commercial application that you cannot change the code, on MariaDB it will be faster out of the box.
Talking about subqueries, is there also a concept like common table expressions that you can use in MariaDB?
What do you mean? On columns?
In SQL Server, you have technology that you can say, okay, you're creating a virtual table, a common table expression,
yes.
a CTE.
Yes. It is, I've talked about it, it is called virtual columns. And,
okay.
I have removed the example here,
Okay.
but basically you can add a column to a table, and that is a computed function from another column.
Okay.
So you could do a CRC, you could do a reverse, you could do whatever function.
Okay.
There is a list of functions, not all functions can be used, and you can index the computed code. So if you have 500 million users and they log in using the email, the index on the email will be very expensive, while you could have an index on the CRC, and this can be automatically computed without changing the application.
One question about the optimizer. Programmers can now get away with writing crappy SQL.
Yes.
Yeah.
So we are not.
Doesn't take away good behavior.
By the way, he's a programmer.
We are not promoting, of course, badly written queries, but subqueries basically on the mind of the developer is natural to write subqueries. But MySQL has never been optimized for subqueries, and when you were doing a subquery, for each record of the subquery, you were executing the parent query. So that would lead to a lot of computation just to maybe retrieve 100 records. You can now write subqueries and they will be fast in MariaDB. That's
usable.
and
That doesn't give you the right to write crappy code.
Yeah.
It does actually.
we have optimized the joins. So if you do like a table-to-table join of million records each, there are some optimizations that allow you to do faster bulk operations, and you don't need. Before, MySQL was using 64 records at a time. So if you compare million records with a million records, that can take time. These optimizations are a lot improving the join implementation. And some other optimizations. So my invitation here is to read the optimizer switch, which are the features you enable and disable in MariaDB, and look at what can benefit to your application. Good addition in MySQL MariaDB 5.3 is what is called group commit. What is group commit? It is an InnoDB feature that if 1,000 people are committing at the same time inside MySQL, that will require 1,000 physical writes on the disk, and that is expensive. A normal disk can do only 200 per second. So the group commit will, one transaction will wait for others to be committed at the same time, and they will be grouped, and they will do only one physical sync to the disk. So you can multiply your capacity of transaction per second just by having this feature. This feature is available in MySQL for a long time, but when you use replication and you enable binary logging, that disables this optimization. So we have re-enabled it again for replication. This graph has been done by the Facebook database engineers. This is the yellow line is the original MySQL. Of course, Facebook, they have quite high traffic, so they have created a patch version of MySQL to try to re-enable the group commit. And the original MySQL developers working at MariaDB have created also their own patch. And that that allows you to again use replication on full durability on your code. MariaDB 5.5 so was came in April 2012. And it is now MySQL 5.5, so it is not based anymore on MySQL 5.1. Plus, all the features we have previously added, they have been reported to MySQL 5.5. Plus, again, new features. So, a better thread pool implementation. You can use skip replication in your queries so that this statement is not replicated. If you do a complex query, you can tell the optimizer, okay, once you have scanned 1,000 records, stop computing the query and give me the result. And the speculative information for the next MariaDB, which is MariaDB 10.
As you was mentioning at the previous slide, different implementation on Linux and Windows. I mean, there's always been a problem because, I mean, the simplest thing is about case sensitivity.
Yes.
Is this still available, or is this still an issue?
It is still an issue, yes.
File system level is.
It's not related to the database, it's related to the file system, it's not to the operating system. So migrating from Microsoft to Linux, by comparison?
Well, I mean, you have a switch that you can actually, let's say, normalize the naming scheme. Is there any, let's say, negative impact on performance using that?
No. It is basically, converting everything to lowercase.
Exactly.
So there is no very low impact.
Because, I mean, the situation is that, unfortunately, on the default settings on Linux and Windows are different.
Yes.
Even though I'm installing the same product, and I have to manually activate
the lowercase in Linux. Yes.
So, I mean, it depends. I mean, you can have the situation about a heterogeneous environment where you need to have replication between systems on Linux servers against systems on Windows servers. I mean, some clients have it, I guess.
Yes. A lot of people.
It was actually very interesting to have this kind of impact. Talking about different implementation, does it also mean that, let's say, the number of transactions or commits varies on the different servers?
Out of the box, we see a performance decrease by switching to Windows, based on the operating system implementation. A lot of work has been done on the thread pool, which is another difference, but it is enabled by default on Windows and not enabled by default on Linux. And that gives much higher transactions per second than out of the box. But there is no actual work being done to make it 100% compatible depending on the operating system.
I have a question. It's concerning MariaDB. Traditionally, MySQL has very good Linux support.
Yes.
Because that's what I think
90% of the installations are on Linux.
What about the other open source operating system?
The BSD, for example.
Yes, FreeBSD.
What is the operating system?
Support FreeBSD, for example.
Oh, there is you need to compile it. There is no FreeBSD binaries.
Because generally what we do with FreeBSD, there's a guy who maintains report and he submits patches to MySQL, but recently this has been very hard since Oracle took over.
Exactly. We have the same problem because each lower version of MariaDB, 5.5.20, 5.5.21, 5.5.22, is based on the version from Oracle, and we need to refix again the bugs.
So you have to forward the patch.
There is no change logs always. It is very obfuscated, and we have a big problem with that. And our developers are having headaches to make it still compatible.
Because generally what they do, they put all the patches in one big file.
Yes, and they don't say anything. You need to have a support subscription to read the change. So the mainly supported platforms are
it's like, for example, if FreeBSD decides to duplicate MySQL from Oracle and try to work closer with MariaDB, is it more open to
yes, but right now we are still a fork from MySQL, so all the mainstream from MySQL has to come to MariaDB, and we have the same view as you. We don't have spies inside Oracle to tell us. So we have the same.
For example, if we submit patches for MariaDB itself.
Yes, it is much more open. It is much more open.
But do the Oracle guys take patches from us?
We do submit patches to.
Okay. Are they open to?
And the developers, they rewrite the patch in their own way, and then they put it in the mainstream. Because they don't accept external contributions unless you give full write properties.
What will happen in the future if MySQL becomes fully paid, or Oracle just closes?
The servers are migrated to MariaDB. Google is a big sponsor for MariaDB, so they are paying all developers to implement features. One of them is the multi-source replication, and some other big names. The other projects we have with MariaDB, so one is the MariaDB Galera cluster. So Galera is a plugin you can install in MySQL, in a Percona server, or in MariaDB. So we provide a fully built clustering solution. We have a C client library, a GDBC driver, and the Microsoft driver that was recently released. And they are all in an open source license. Could be LGPL, could be BSD, I don't know the history. We also have developed audit plugin. That was the missing feature, I forgot, which is fully open source and with even more features than the closed version. So, agenda for these new features, we have enhanced replications, more storage engine, enhanced again the optimizer, enhanced administration commands, and taken some data from MySQL 5.6. So why we didn't fork MySQL 5.6? Because, as you know, the MySQL developers have left Oracle and they have hired new developers that didn't work on the main code base. So the new features they are creating are more bug prone, because when they create something, they don't think that this is related to this and this, while all developers, they already know how it is developed. So this is not the best way to develop a software, but that's the actual state. So MySQL 5.6 has been announced as production ready by Oracle in 2012 or 2013. We have less than 5% of our customers using 5.6 because we don't qualify it as stable, as production ready. So MariaDB 10 has taken what is considered as stable from 5.6, and everything else has been implemented, all the features. So we have added global transaction IDs. So what is global transaction ID? If you have a complex replication topology, if you lose the master, which is in this case A, how do you reconnect B and C? It is almost impossible, or it is a lot of manual work. With global transaction ID, you can say, I pick up any of my server. So in this case, I pick up E. I say to B, now you replicate from E. I say to C, now you replicate from E. And it is only one command. Just start again replication from them. And they will get the data and be part of the synchronization again. When A comes back, you say to him, replicate from any of the servers, and then it will be 100% consistent with everyone. These are the commands to set up global transaction ID enabled replications. We also support crash safe slave. So a lot of people have 10, 100 slaves for reads because they want to scale reads. And if a slave has a failure and he starts again, he may try to replicate from a wrong position because this was written in a file on the server. With GTID, it is now stored in an InnoDB table, and InnoDB is 100% crash safe. So the replication will resume from when it's done. We have multi-source replication, so 3 different servers replicating to another server. It is compatible with GTIDs, and it is external contribution not by Google, but by Taobao. You have the same commands as before, but you just add a name to your replication stream, and you can have as many as you want replication channels from many masters to one slave. We have implemented parallel slave, but different than Oracle implementation is that it automatically detects independent transactions, and it can apply parallel statements even on the same table. And it also preserves the commit order, so you will not see inconsistent data on your slave at any time. A lot of storage engine has been added, so you can now connect MariaDB to Cassandra. If you have a Cassandra rig, you can do SQL statements against NoSQL layer. There is connect on some others that I will explain. So you can join MariaDB table with Cassandra table. There is automatic data mapping. And you can connect multiple MariaDB to one Cassandra. So I don't know if you use Cassandra or Hadoop or some other NoSQL solution. So that adds the SQL on the NoSQL. Connect is a storage engine that allows you to read files, which can be CSV, binary, DBF, XML, INI, and it maps it to a table. So you can do SQL statements against files that are not intended to be a database. It can connect to ODBC, so you can have a table which is a mapping to a remote Oracle server or to a remote Microsoft server and access it using MySQL command. Sequence storage engine is just a sequence number generator that is available. Spider storage engine, I don't know if you have heard about this one. It is basically automatic sharding of your data. So if you have 500 gig single instance database, you may want to split it in 5 different servers of 100 gig each, but you don't want to change your application. So what does Spider do is that it automatically stores data on remote server, but your application connects only to one single server and see the data as if it was only on one server. So it allows you to scale out in writes and reads on your MySQL application. We have added TokuDB storage engine. So TokuDB is a storage engine intended for high insert workload. So InnoDB performance decrease when you are out of memory. So if your data set is bigger than the buffer pool, the insert performance decrease. While TokuDB, so this is to insert 1 billion records, and the insert rate is pretty stable. And it's not related to the size of the data. It is a plugin, so you just install plugin, one command, and you have the possibility to create a TokuDB table. So one unique use case is you can use connect to Oracle table, join result from a Cassandra ring, and store it in InnoDB in one single query. More optimizer enhancements. So we have added engine-independent statistics for MySQL or InnoDB that are persistent, so they are not computed when you restart the server. We have added histograms. This is an Oracle feature, so that we know what's the percentage of data that is present in your table, and that hints the optimizer. Subquery optimizations. I will not explain it again. We have new commands, so you can do show explain for actually running a query. So you have one query that is running for 10 minutes. You want to know what was the explain plan for this query. You just do show explain for thread number 10, and you get the explain plan used to execute the query. You can add the list of plugins that are available. There is a new shutdown command. So if you just type shutdown inside the MySQL command line, that will do what it says. You can kill queries and not only threads. So today you have a long-running query, you kill the thread, and the thread is disconnected. So you get an exception. Now you can say, I want to kill the query 18 for this thread, and the thread is not disconnected. So that prevents some race conditions. You have more information for monitoring, so you can have memory used per process. So some complex query will use more memory. You can see what query uses what much memory, and you can also have your local connection memory usage. Roles have been implemented, so same as in Oracle. If you have 20 DBAs, you need to grant the particular rights for your 20 DBAs. That is very expensive in administration. Now you can create a DBA role and grant the DBA role to a user. Delete returning. So when you do a delete, you don't know what was deleted. Here you can return all the primary keys or the full content of the data that was deleted. And some other features. What we took still from MySQL 5.6, so we took InnoDB, MariaDB is owned by Oracle since 2006, and MariaDB has been actively developed. So we take it. We took the performance schema, some online alter commands that are new in 5.6, and some other features that we consider as that mistake. Last 3 slides. So the MariaDB audit plugin is for companies that require high security standards, where you need to log everything that is happening in your database. So it is a plugin, very lightweight, that can trace which user access which data on a query basis or on a access pattern basis.
Okay, actually, I was just about to say, I mean, this is not only for high security, this is in several countries, this is by law.
Yes.
Then it has to be
audit. Yes.
Does the audit plugin satisfy requirements for PCI compliance?
Yes. We have customers in Germany mainly that are using the audit plugin for PCI.
Yes.
You should show this to our government.
They don't know what audit is.
So it is the cost is very light, and it can store the data in a file on the same server or to a remote syslog server. So by doing that, you can ensure that someone breaking the system, he will be logged on some other server.
Remote syslog.
So new parameters are available. You can log three types of errors. When someone connects, disconnects, and fails to connect, like a wrong password, you can log all the queries with user information. They are logged as executed, so they might reveal sensitive information. And you can log table events. If I have a view and I query a view, and my view is accessing 5 tables, we will log the 5 tables that you have accessed. And that's the example of it's a snippet of logging.